So the purpose of this video is to give TBC users some hints and some tips to some of the tools that are available within Trimble Business Centre to extract information from SX12 data. And of course that could be photography and it could be scan data, and obviously it covers the SX10 total station as well. So we're going to first of all look at how to extract information purely photogrammetrically. So we're using the photography, but we're doing photogrammetric extraction. So from the plan view, from the 3D view, we can select any of these icons and we can right click and we can choose new station view. And what I actually like to do is I like to split the screen. So I drag one of the views to one location, and we need two views that can see the same object to make a purely photogrammetric extraction. Because we're doing things photogrammetrically, I'm going to go to the view filter manager, and I'm going to turn my scans entirely off. And we're only seeing the photography from the data. We're only seeing the photography from the SX10 or SX12 instrument. We're not seeing the scan data. We can do photogrammetric extraction using any of the cameras, but to get the best accuracy, then we certainly want to be using either the primary camera or the telecamera. So we can go to Survey Photo Point. We can give the point a unique ID. We've got this option to automatically search for observations. I'm going to turn it off. But what that will do is if I select one pixel location, then it will basically do a search for the same pixel pattern in another image. And it searches the epipolar line to try and find that same pattern. But for the most accurate measurements, I often like to just do it manually. So we can go to one image, we can make a measurement using this virtual crosshair, and then we can go to the second image. And what I should have had this turned off is this automatically advance on pick. So what it's doing is it's actually changing the view, and because I've got two views open, then I don't need that. So I'm just going to go back to the previous scan station. So I should have turned that off before I did it. So we've made an observation to this feature here at the moment. And then in the second view, we can actually see this epipolar line. So essentially it's a horizontal vertical angle vector coming up that doesn't have a defined distance. That's the epipolar line, and we can see it broadly going through the same top corner of the E. And now we just need to make a second observation. And we can carry on and make a third observation, a fourth observation. But if we jump to the 3D view, we can essentially see in 3D space that we've got the intersection of these two vectors. And if we actually just choose compute, we've now calculated the coordinate for this position purely photogrammetrically. Now, this is often the most accurate way to extract data from SX series instruments back in the office, but it does require geometry to be correct, and obviously there are tools within Trimble Business Centre that show you whether the geometry is correct, and we're not going to dig into these on the scope of this video. But that is just a very quick summary of how to extract data entirely photogrammetrically from Trimble Business Centre. So the next thing I shall demonstrate is what happens if you've got photography from one location, but you don't have photography from another location. And then we can still use the photography, we can still extract things photogrammetrically, but we don't have the option to extract it entirely photogrammetrically. And it's best explained just by running through the process. So just to explain some of the advantages of using the photography, we've got the scan data turned on here, and if I just turn the photography off, so we'll just turn the photography off, and we can see that when we're looking at scan data, we don't really see contiguous data. And when we zoom in, we basically just see a heap of points and we lose the data. Whereas the nature of photography is the data is always contiguous. So when I zoom in, yes, it's getting obviously more pixelated, but I'm still getting a much clearer impression of what's actually there. So if we've got photography from one location, we've got scan data available to us, but we don't have photography available from a second location. If I was entirely using the scan data, then I might not be able to see. And we'll actually jump across to another setup to do this. So we've jumped to this other setup here. And if I was entirely dependent on extracting the data here, I'm just looking at the lettering here from the scan data. If I turn off the photography, so I'll just go to the filters and turn it off, then I'm simply not going to see that clear enough to be able to extract any of the information. We can see the lettering is vaguely readable, but very, very difficult with a lot of difficulties. So the method I'm going to show you is by choosing the depth plane tool. So we go into define new depth plane. We can give it a sensible name. So I can call it East Plane 1. And then I need 2 points to define a plane. So the assumption is that the assumption I'm making is that the points I'm picking are going to be coplanar with the points I'm going to extract photogrammetrically. So they're on the same plane. And then the other assumption is that it's a vertical plane. So we can define 2 points and then we can hit OK. And now what I want to do is make sure that we turn the scan data off. So we're not going to snap onto that scan data. And what we can see in the 3D view is we've actually got this plane. It's shown graphically just as a very narrow plane, but it does extend to infinity. But obviously you will have error propagation. So we'd recommend if you're defining a plane that you're always clicking the points outside the areas that you're wanting to extract. And now we can just go to CAD and we can go to Createpoint. And I'm just going to call this one DCM 101. And we can just choose purely CAD points, and I can digitize as I like. I'm just doing this very quickly, the key points that I want to extract. So if we want to extract, we've shown how to extract points. If we want to extract lines using the depth plane tool, then we go to line string, and then we don't need to name it. We can choose our layer, of course, and then we can digitize on this cutting plane and on this depth plane rather, and we can just digitize our way around it. And I'll just set that to autoclose, and we can see that we've actually digitized that line string onto the plane. Now, what's subject to error is basically if this plane that I'm digitizing on is not actually truly vertical, then there will be subject to error. So that's something that I need to be careful of. And the second thing is that if I have any station setup errors, then we will see that again potentially in the setup. So if I jump to another view here, we can see there's a slight step in the data, just a few millimeters, not much. But that is reflecting, actually, when you dig into it with this data, it's just reflecting a little bit of laxity in the actual station setup rather than in the methodology itself. So this method is still using photogrammetry, but essentially the photogrammetry, instead of intersecting another photogrammetric measurement, we're intersecting a defined plane. Now, just staying with the same data, if I just turn on the scan data once more, we'll show you another way which is not restricted to purely vertical planes. So to do this, then we need to use our cutting plane tool. So we can go across to our cutting plane. So we can go to point clouds, we can say plane manager, and I'm going to define this plane by 3 points. So I can just call new, give it a sensible name. And I'm going to choose 3 points, and I'm selecting 1, 2, 3 points. Now, I'm just going to do that again, and it's just going to mention something that's quite important, is that, first of all, I've still got the depth plane off. So while I think I'm maybe snapping points, potentially I'm actually snapping onto that plane that I've just defined. So we need to make sure that we turn the plane off when we're done with it. And you can see that we can delete planes. So this is in the depth plane. And then we can also name them sensibly, and we can jump between them at will. But this is something, the depth plane is something entirely different from the cutting plane and the plane manager. So the depth plane are purely photogrammetric planes that are only for vertical. The plane manager is basically can be defined by all these different ways, and it's not available for a purely photogrammetric measurement. So easy to get confused between these two different types of planes, but they are separate things. So we need to turn this off to none. And the second thing I was going to show is this parallax view. And it's very important that we have the parallax correctly set when we're using the SX12 when we're picking scan points. So what I always like to do is just select here and click, and then we make sure that the photography is purely aligned for the range that we're currently working on. And then we can define our 3 points that we want to define that plane. So I'm going to, it's called east wall. We've defined it, and then we can just hit close. And once we've done that, we can actually now go to create a rectified image. And what we can do is we can actually rectify the photography onto that 3D plane. So we go into the station view, and it's asking where do we want to rectify it. So we just pick both sides, and we say that we want to do it from, say, there to there. It asks me what the pixel size I want to create is, and let's just go for 1 pixel. And obviously we can make some calculations about what image we're using, type of image we're using from the SX series instrument to see how valid this is. So there's no point in creating a pixel size of 1 millimeter if the raw photography is a pixel size of 5 millimeters. So we can say OK to that. It's now created an orthorectified image. And this is now a 3D object, and it could be in any orientation. And it's something that we can actually now use within Trimble Business Center. So if I now just go in my 3D view, and we can now see that this object is now sitting in 3D space within Trimble Business Center. To actually extract further information from this, then we actually need to go to the cutting plane view. So we go back to point clouds, and we go to cutting plane view. And of course, we've only defined the one plane in this project at the moment, east wall. And what I will see is that ortho-rectified image now in that plane. And to extract information from that, then we can just go back to Createpoint CAD. And then once more, we can insert, and I'm just doing this very quickly, some points. And once again, then we can use the polyline tool this time. And then if I just wanted to draw across the top of the T here, I do have the option to use the shift command here to hold it in the set direction. And if I go back to my 3D view, so if I close the cutting plane now, and if I go back to my 3D views, then I should see that data. This is a georeferenced image, so it comes on through in the View Filter Manager georeferenced image, and we can just turn it off, and you can see here the points that we've extracted. If we go back to Station View, again we see the points that we've extracted. So that is extracting points, essentially again photogrammetrically, but from a single station, but using a defined plane within Trimble Business Center. Another method I want to touch on is using the virtual DR. And it's a very quick method, but it's just something you need to understand the mechanics of it to make a judgment whether it's suitable for you to use it on a project. So To use virtual DR, I can just, from the station view, go to Createpoint, and I can again choose easting, northing, and I just need to tick this little box, virtual DR. And I can select any point that I want a position of. So let's just see the corner of this E. And again, I got the photogrammetric tool to allow me to make a measurement. And let's just turn the scan data on. No, didn't quite remember you actually have to have the scan data visible, but that is possibly right. And it is right, you actually need to have the scan data visible. And you can see what essentially we have here is we've got a position being extracted. And if I just choose add, we'll see that 113 extracted. If we jump to the other station view, then we can see 113 is being extracted. Now, the way it works is it basically takes a horizontal and a vertical angle from the photogrammetry, and it takes a distance from the nearest point in the point cloud. So you just have to be aware that if we're at a very obscure angle, a very oblique angle, then potentially that has going to have a distance that might be too long or too short. So it can be a very accurate method. At other times, it can be less accurate. But if you understand the mechanics, then the user can make that judgment themselves. So the last thing I just want to emphasize with all of these techniques, whether they're purely photogrammetric or some of the combined techniques that we've been looking at, is essential. It is essential to QC the result that you're getting afterwards. And often the easiest thing to do is actually open the point cloud, and we're just looking for gross errors, or open the other station view and just make sure that whatever's being calculated is looking okay. So the QC check at the end of a calculation is always very important. So hopefully that's helped with some of the techniques to extract information from SX10 and SX12 data within Trimble Business Centre.